Today is July 7th, 2015. This should be fun. I'm sure my readers are already familiar with a lot of the things that I say and talk about, but I want to explain something. Definition making is essential for people to understand what it is is being referred to. And when I have a new theory that I'm drawing up, I have to redefine what I'm talking about. That way, the expansion of the object can happen by defining it. For instance, establishment physics and astronomy and cosmology and all the above has a definition of a star being: a star is a luminous sphere of plasma held together by its own gravity. I'll go over that later. It appears to be a good definition at first glance. According to stellar Metamorphosis, the definition of a star is a radiative, gravitationally collapsing nebular cloud which evolves into a rocky, differentiated life-hosting world. That is one hell of a definition, and I'll show you why. This definition here is very, very weak, very, very poor, and limits the creative minds of those who wish to study them. It places the star into a little box. I'll show you how. It says it's a luminous sphere of plasma. Okay? Now, stars, they cool, don't they? They stop being luminous. They can radiate, okay? Rocks and minerals radiate. Gas radiates. All matter radiates. But to give the definition of a star as being luminous is very poor, especially when the majority of stars are not luminous. The majority of stars are even called something else. They're called planets. Those are the ancient stars. So that's very poor. That word can be replaced by radiative. Sphere is not too sure about sphere, because some of the objects that we see are oblong and they're not perfect spheres. Okay, so the sphere, the Earth isn't even a real sphere. It's I don't know, it's like squished because of the angular momentum of the body. It's spinning, so it gets squished. It's not a real sphere. That's another idealization that can be replaced. Notice I don't have sphere up there because sphere is irrelevant. Most objects are squished in the center. Plasma, okay? Plasma is one phase transition, or one phase. You also have gas, you also have liquid, you also have solids, you also have supercritical matter, which I'll go over in another talk. You know, we have all these phases of matter that stars experience as they evolve. So to say it's plasma only, that's another mistake. And then it says, held together by its own gravity. Placing a force, a singular force, for the entire thing is very poor, because a star actually has gas pressure. A star has electromagnetically forced material when it's comprised of a lot of plasma. So to say gravity alone keeps everything in the conditions that it's at, I don't know. There's more to the picture than what meets the eye. So it's kind of ignoring other forces involved. And that's another poor definition. So basically, their definition of a star really is just something that's held together. I think this is a much better definition up here. The star is a radiative, gravitationally collapsing, which means it gives it something of a dynamic nature. A star is dynamic, okay? It's forever changing, cooling, shrinking, Even Cepheid variables, they expand and contract. I have to look more about those. And the fact that it's collapsing gives it more of a dynamic nature. If you noticed in the other definition, it says a star is a luminous sphere of plasma held together by its own gravity. No mention of anything being dynamic in there. They have the star as static. Now that's perfect for the mathematicians because they can draw the formula and then boom, the star sits in a little box again. That's very, very, very poor definition making. Nebular cloud, obviously, if a nebular cloud collapses, the Helmholtz or Kelvin-Helmholtz mechanism will cause the star to heat, but being that they screwed up royally in the 1930s and 40s and tried to place fusion inside of those things, they've been lost since. Which evolves. Now that is a major dynamic construct that we should apply to stars because they are incredibly dynamic. They have CMEs coming out of them when they're young, solar flares, solar wind, weather, okay? Every single phase transition from condensation, sublimation, to effusion when you have a supercritical liquid penetrating a solid and allowing it to change its composition. You have incredible amounts of evolutionary processes happening inside of a star, and you need to include that in the definition. And eventually it goes into a rocky, which means you automatically connect the star to planet formation itself, meaning that's an automatic clumping together of the two concepts to make it to where it's, no nonsense. This is actually what stars do. A star evolves, cools, and shrinks, and forms a rocky interior. And differentiated as well, because the material is obviously different. Not all elements act the same way. So this gives a dynamic structure to elemental compositions, minerals, the molecules, that kind of stuff. Life hosting. Oh my goodness. That means that stellar evolution itself is, or life as we know it, is a byproduct of stellar evolution itself. And adding that into the definition of a star makes it an even richer definition than anything that could be ever offered by establishment physics with their static structures that ignore phase transitions, that ignore other forces. Basically, you have a definition that's held together with nothing at all. It's a definition they designed before they even understood what they were looking at through telescopes. We still have definitions for stars based off of 18th and 19th century and 20th century reasoning. And here we go. This is what I believe to be a better definition of star. For those of you who want to leave me questions and comments concerning this definition, or if you want to improve on it, be my guest, because I'm open for suggestions.